Hi everyone, and welcome back to Senior.js Dev. I wanted to continue from the last session that we did on extraction, and that is because as we begin to extract our code into several functions and files, what we start to see is more and more dependencies building up in our project. And so as a senior developer, it becomes really important to get good at managing dependencies or dependency management. This is often referred to as dependency injection, and there are three main types of ways to inject dependencies into your code. Now, I know this is kind of a scary topic for JavaScript developers, not so much with other languages, and it's not even for JavaScript if you understand the concepts and terminology that are involved. Okay, I want to talk really briefly about one way to visualize the architecture of every application that exists, and that is as a graph. And all of the nodes in this graph represent modules of your project. And the arrows are dependencies. So modules depend on other modules. Other functions depend on other functions. I have my root module here. This is like a main function. This is where the application starts. And then it calls other modules. These might be top-level web components like pages and navigation, etc. Those call into our branches. These could be things like services or where business logic lies. And then there are leaves, which could be things like utility functions or third-party libraries, things like that. And as your application grows, the way that you manage or architect your dependencies makes your application easier or harder to test. Specifically, it makes your modules easier or harder to test. When you have a lot of modules and a lot of dependencies, isolating the dependencies of your module becomes especially critical in order to test it effectively. So let's jump into some of the strategies and architectures and techniques. So let's jump right into it with the first way of implementing dependency injection via arguments or parameters. So this is a very common thing that we often do is when we call a function, we will pass in arguments, we'll pass in parameters. Now, as we're passing in data, we can also pass in, let's say, a function like a callback. And that function is what's used by the callee, which is the function, in order to do its work. And the callee doesn't know what that callback is actually doing. So how does that work? A very quick example. All right, I've got my utility functions here, and I've already defined one for add, which we'll look at later. But I want to implement this one, which is add money. A little bit different than adding two numbers or two strings being concatenated, because we don't want to trust the floating point integers of JavaScript that does some funky math. And so instead what I want to do is use a library to help me implement the complexities of adding two large numbers together, including floating point. So I have this hypothetical mmath library. Now, where does it come from? Well, we're talking about implementing the dependency management using arguments and parameters. So what I could decide to do as a developer is just to pass in this magical function as another parameter to the function call, such as that. And as you can see, magically, that dependency has now been resolved. My function is going to assume that mmath is an object, and it has a property called add, which resolves to a function, and that function can then take two parameters, and I'll do it this way. So mmath can add a and b together, return me the correct result, and now I've added two sums of money together properly. Awesome, that was easy peasy. And that's really the benefit of the first way of doing dependency injection through arguments and parameters, is that the callee, which is this function, doesn't really need to know where that dependency came from. It's just being passed in, it's going to use it. And the benefit here is that it's very easy to test. This would obviously be in a separate .test file. Let's create that right now. Okay, so now what I've got is a very simple boilerplate of my test suite that I want to implement. And I'm ready to test add money. And I'm going to pass it different mmath objects to see what happens when it returns. So I need to create a mock object with an add property that is a function that takes a and b. That's the signature of the function. And here I can decide to pass fake. In this case, my mock mmath library is not going to use a and b. I just want to make sure it was being called. So let's now call it with a result equals my add money of 42 and 43. And I'm going to expect that my result to be, what's it going to be? Is it going to be 85? No, it's going to be fake. I expect my add money to call, oh, I need to pass an mmath here. I expect add money to grab the add function here, call it with any two values, and that function is going to return a fake, and I'm going to make sure that fake is returned. So let's run that test really quick. And it looks good. I'll run that a few times, and every time it passes. So let's change our mock implementation of add for mmath. And maybe I'll say a plus a, which means I expect now the answer to be, what is it going to be? Is it going to be 85? Nope, it's going to be 42, 42, because it's going to concatenate two strings together. So let's test that. That's good. Let's give it a false test to see it fail, and sure enough, it failed. Perfect. Okay, so that's the benefit of managing dependencies or dependency management through arguments and parameters. Of course, for web components, the way that we implement injection is by adding a prop to the web component. So in this case, if I wanted to inject add money, I would just import it from my utils and then pass it into a component like we do any other prop, which is add money equals add money like this, for example. And then my component could just deconstruct the add money off of the prop object to do its calculation. That's what injection by arguments and properties looks like for web components. The next way we're going to tackle dependency management is by imports. So let's go ahead and change our utility function a little bit. By instead of expecting mmatch to be passed in as a parameter, we're going to import it as library. And now we can see that our test is failing, but the API has changed. Did you notice? Now it only takes 2 parameters instead of 3. Now let's go ahead and fix our test in order to be compliant. So I no longer need to create a mock mmath object, and I no longer need to pass it in. So let's test this. Now mmath has a couple of requirements. We want to provide 0.00 as a requirement for the format of string that it's expecting to be passed in. And the result of this, well, it should be 85.00. Let's see if that worked. Hooray, it passed. So I just want to highlight the differences here. I now have lost a little bit of control with testing add money because I can no longer easily change the result that gets passed back to me unless I want to do a mock. And I can do that with jest, for example, by creating a mock of mmoney.add, and then jest is responsible for, at load time, swapping that add function in for the original add and using my mock function instead. It is possible to change the functionality of a library, but it's a little bit more tricky. So that is import as a dependency management strategy. The third strategy is called inversion of control. Maybe you've heard of that before. I want to take you through a couple of examples to explain it in the simplest way possible. Because inversion of control is really a simple concept. It's the idea of, well, you're removing control away from your function or your callee, and it's calling into a third-party registry to say, I need to do something. I want you to pass me back the thing responsible for what I'm trying to do. Let me give you an example. So inversion of control, first of all, the main concept is a registry. So let's look at this very plain vanilla, simple inversion of control implementation. I have my registry here. It's just a simple object. And I'm exporting a couple of functions to help manipulate the registry. I can add a value for a label, providing it the component to do that work. That component is a generic term here. It's usually a function, but it could be a raw piece of data. It could be anything. And a provider. So if I give it a label, I want it to provide me that component, that function, that data, whatever, that matches that label that was added originally. This is the whole basis around inversion of control. It's very simple. The way that we can use this is in two steps. First of all, it's setting up the registry and then pulling the registry values out when we need them. So let's work on step number one. I do that here for our simple demo, which is in a function called init. Init needs to get called when the app boots up, bootstraps. I'll show you that in a second, but let's assume for now this gets called when the app starts. What we're doing here is pulling the add value for from our inversion of control registry. I'm also importing this add function from my utilities, and I'm matching the two by saying I want you to add a value for the string add will provide this function to whoever calls for it. So going back to our inversion of control code, I've just called this function, provided it the label of string add, and a component, which is the function to do the adding, a plus b. Now my registry is all set up, but something has to use that registry. It has to get a provided value. So let's look into our component number one, and we'll see how we are using the inversion of control system in order to extract that function so that we know how to add two numbers. So here I am, I'm importing the inversion of control, saying, okay, your job is to provide me values. I want the value for the string add. So you can imagine this now add is a reference to the function in the registry. In my very simple component, I then use add, assuming it exists. I'm going to use add and pass it in two numbers, a and b, 1 and 1 for component number 1. And very similar to component number 2, I just pass in 2 and 2. So that should be 4, and component number 1 obviously should be 2. So let's open up our app now and see what happens when we run this live. Component number 1 says I can add 1 plus 1, that equals 2. And component number 2 says I can add 2 plus 2, and that equals 4. So it seems to be properly getting the handle to the add function, which is perfect. And notice component number 1 does not know how to add a number. There's no definition here for that functionality. Now, why would we want to do this? Well, a lot of this actually, again, comes down to testing and the ease or difficulty of testing. So let's look at a test for component number 1 and look at how we can set up this IOC registry by providing a mock implementation of our add function and then testing to make sure that it was called, for an example. So here I have my boilerplate set up for component number 1. I've defined an add mock function, which I then define here using a just mock function. And then I set up my registry using add value for, and then add and mock. Now after each test, I'm going to clear my mocks so that the calls reset on this mock function. And I do a very simple call to the target. Now remember, we are rendering our target, which is component 1 here, but we're not using any JSX library to help us render into the DOM. You can do that, and you should do that for components, but for now we're just going to trigger the target by calling it as a function. These are function components in React. So it makes it very easy, at least, to get the target run. So I'm going to call this function, and really what I'm testing is that this component returns something. It could be anything. It's going to be an object. And I want to test that it did actually call my add function, which is right here. I just want to make sure that that happened in this test. So I'm going to render my function component. I'm going to make sure that something got returned. So element is truthy. And then I'm going to start looking at my add mock function. I'm going to make sure that it was called exactly one time. And I'm going to check the parameters that it was called with. So I want the first call, which here is at index 0, to equal 2 arguments, which is 1, 1. And when I run this test, you'll see this component passes. And if I want it to fail, I can say, I think it was called twice. And sure enough, it failed. It's expecting a length of 1. It's expecting a length of 2 because I told it to, but it actually received a length of 1, which is actually what I really expected. And when I change that, my test passes. So again, the benefit of using IOC, a lot of it comes down to testability and it being super easy to set up your test scenario, set up your dependencies that get used by the component. Now, I know what some of you are thinking, which is, you're writing this in React. Why don't you use React out of the box IOC system? And some of you may recognize this looks a lot like context. And so I have another quick implementation here to show you using, instead of this custom IOC registry, using an out-of-the-box implementation of dependency management using IOC, and that is in this app.context.jsx file. Again, a very simple example, but I'm now importing React to use its create context and its use context hook. Let's look at how we can use React context for our IOC instead of a custom IOC registry. Here I'm going to create an IOC context, and here I am creating my registry, which is add is the string, it's the label, and add is the function here of the actual implementation. Now when I wire up my app component, I wrap it using a IOC context.provider. So remember, this is going to provide a value to any of the children who want to pull this add function. And the value is going to be this registry, which again is an object or a dictionary. And then my component number 1 and component number 2 can be nested inside. And the way that my components grab that add function is by this syntax. I have a use context function, so I would do that with import use context from React, like such. And with use context, I pass in the IOC context object that was created above here. So this would actually probably need to get exported, but I'm leaving a little bit of that out just to show you that this is how they tie back in together. So with this, I'm now getting my registry object because that is the value that was provided by this context, which I wired up here. Then I am decomposing the add function by referencing the add label or add property off of this object. And then I have my reference, and I can easily use add just as I did before by passing in 2 numbers. And let's go back into add. You can see this is the API that we are implementing here. So these can be numbers or strings. Now, just like with the original simple homemade IOC implementation, we can use React context in order to wrap our components inside of a test or a mock provider that provides values that we want our children components to pull off and use. Which means when I write my test, let me show you here quickly with another boilerplate test suite. I've got my basic boilerplate set up now, and here's how we can go about setting up a mock context for our child component. And I just realized I don't want to import app, I want to import my component number 1. It's going to be the child that I'm going to wrap inside of my mock context. So the way that I do that is, and in case you're wondering, before I go any farther, yes, we do want to use a third-party DOM rendering library in order to help us compose these components together. It's going to be a lot more difficult than in our test for an individual component here, where I just initialize or run or instantiate the component itself. With composition, it gets a little bit more tricky, and so I'm just going to show you the concept, and this test actually won't run or properly pass its test. Nevertheless, this is sort of pseudo-syntax, let's call it that. So what I'm going to want to do is export this context, and I'm going to borrow this code for my test and put it right here. And this registry is what I'm going to mock. So I'm going to say const add mock equals just function. It's going to take AB, but it's going to return a fake string, a string of fake. And my value is now going to be add, but it's going to point to my add mock, like that. And of course, this is going to be target. And then I can also expect my add mock dot mock dot calls have length, oops, of 1, like that. So again, this test won't pass. We would like to have a helper library here to help us render this component into the DOM in order to do this web component composition. So you can kind of just ignore this for now. It's just sample. But once this actually renders into the DOM, we would expect that the add function would get called once, again, right here in our rendering of the component. And that would equal 1 here. Right now, obviously, it's 0 because the app isn't rendering into the DOM. But thanks to this mock context, we are able to provide any values that we want to the child component. And this is the real power and benefit of using a dependency management system based on inversion of control. So the child doesn't really know what it's calling. It just knows how to grab it, and it can use that, whether it's provided in a production scenario, a staging scenario, or a testing environment like we're doing here. It doesn't know, and it doesn't care. And that's how you build testable code. All right, I hope you enjoyed this little explanation, and I hope to see you next time. Until then, enjoy coding.